Welcome back to part 3 of 4.2. So we're looking at example 4. So for t between 0 and 2, a bug is moving along the x-axis with b of t equals t squared times sine t cubed minus 1.5t. And there's a little bug right there. So again, our interval is between 0 and 2, so we're just looking at this part of the graph right there. So find a of 0.7. Is the bug speeding up or slowing down at t equals 0.7? And explain your reasoning, right? So again, if it's speeding up, that means that the bug is both the velocity and acceleration are going in the same direction, right? They're both negative or they're both positive. So let's see what's happening at 0.7, okay? So first, let's find a v of 0.7, which looks to be negative. All right. So again, if you guys can always use Desmos for this. Desmos will set up the equations for you. You just have to set up the equations. And then we're going to see v of 0.7, which is negative 0.318. And then a of 0.7, which is negative 92.05. All right, so let's go back into our notes. So we're going to say v of 0.7 is equal to negative 0.318. And then a of 0.7 is equal to negative 0.92. Was it 92? Let's double check. 9205. 9205. 9205. All right. So here we can say that the bug is speeding up because both v of t and a of t are negative. All right. So remember, if both are negative, that means it's going faster, right? It's gaining speed. Okay. And then find any values of t in the interval between 1 and 2 when the bug is at rest. So you guys have to remember that the bug is at rest when it has to be v of t equal to 0, right? So when does v of t equal to 0 between the interval 1 and 2, right? So here, if you guys notice right there, it's equal to 0. The bug is at rest at 2 moments, right? Here and here, according to our graph. All right, then again, we can go back to Desmos. And then you guys can see the graphs. You guys can also change the setting here, right? If you guys change it to, I would do, since they're asking me from 1 to 2, I would do 0 to 3. And then the y-axis, I can just leave it like that. I can see the graph clearly now. So again, be careful here. We're looking at the red graph only. So when does v of t equals 0? At that moment, 1.224. And then 1.801. So again, we can say the bug is at rest at t equals we said it was going to be 1.224 and 1.80. So 1.224 and at t equals 1.801. because V of t is equal to 0. All right. And then on the next one, it says find the open intervals on between 0 and 2 when the bug is moving to the right. So the bug has to be moving to the right when both velocity and acceleration are positive, right? So here, if you guys notice, we can see that velocity is positive when it crosses a first rest point, right? And it's negative when it crosses the second rest point after that, right? Which is pretty much the two values that we found up here. All right, so what we want to do is, again, determine whether it's positive or it's negative. So if you guys look at the graph here, it's positive at a certain point until it reaches there, and then it changes direction, right? It starts to slow down before it changes direction. So we should be looking at pretty much between 0, between 1.224, and it looks to be, again, if we go back to the graph, we look at the maximum right there, and it looks like it's at 1.611. And again, this is just by looking at the graph, right? This is where we notice that V of t becomes positive, and then the slope is positive of the tangent line. That's why I'm picking that right there. So it's always positive until it reaches that value right there. So we can say this is where, so this is the interval. Where both V of t and V of t and A of t are positive. And then it says find the acceleration of the bug when V of t equals -1. So when this, we're looking for A of t. First, we have to find what does t equal when V of t equals -1, right? If we know that. Okay, so let's look for that in the graph. When does V of t equal to -1? And again, there's no harm in using Desmos for this. -1. Can we trace it? About right there. So V of t 1. So if you guys type in the equation like this and you look for the intersecting point, then you can determine at which value it's equal to -1 just by looking at the graphs. In this case, this is exactly what I did, which is 1.8369. So that's the value we're looking for. That's the t value we're looking for, right? So first we're going to find the t value. So t equals 1.861. All right. And then we're looking for that. So we're looking for a of 1.861. We're looking to see what's happening precisely at that point. So let's go back to this. So a of, and then it was the point here. Oops. 1.369. 1.369. I'll correct it right now. 1.36. Let's take this off. So we have -28.87. -28.87. Yes. All right. And that's pretty much the acceleration for that. So an AP exam tip on the AP exam, students are frequently asked to find the time intervals when the particle is speeding up and slowing down, and also asked to justify their answers. Sign charts are not typically scored as justifications by the readers. Instead, the readers are looking for any answer in more of a narrative form. So while students are encouraged to make sign charts because they're easy to construct, the justification must be written a bit more formally and reference the comparison of the sign of V of t and A of t over the interval. So I'm going to show you guys how sign charts work later on. So this concludes part 3.